morning, HOD Professor A.K. Chaturvedi sir, my seminar guide Dr. S.L. Meena sir, seminar coordinator D.P. Sharma sir, faculty members, examiners and my friends. I am Ankit Kumar Mishra, pursuing my bachelor's degree from University Department of Mechanical Engineering, Rajasthan Technical University, Kota. My seminar topic is Hybrid Cold Metal Transfer Welding, a review. Let's start this presentation with the introduction of this topic. CMT is a subset of gas metal arc welding. It works by reducing the weld current and retracting the weld wire when detecting a short circuit, resulting in a drop by drop deposit of weld materials deposited for thin materials. CMT requires strict control of weld parameters. CMT provides controlled method of material deposition and low thermal input by incorporating an innovative wire feed system coupled with high-speed digital control. Hybrid cold metal transfer welding (SCMT) is a type of welding that combines two different welding processes: gas metal arc welding and friction stir welding with ultrasonic vibrations. So now discuss about what is the objective of this study. This study is done to examine the importance of cold metal transfer process and its contribution towards welding industries. And we can say to study about the hybrid cold metal transfer and process of making it hybrid. To examine the various control parameters in SCMT process for no spatter welding and improved weld based aesthetics. To examine the microstructures and other weld characteristics of SCMT. Now moving on the next slide, the characteristics of CMT process. There is two main and important characteristics of CMT process. First is droplet transfer process and second is heat input reduction. Now discuss about the first one. During the standard droplet transfer by conventional MIG welding, as the electrode wire tip make contact with immerse and molten pool, a high short circuit current flows, marking the onset of sudden metals melting such that droplet transfer occurs by surface tension of the pool of molten metal, just as droplet transfer is completed, as we can see in the picture shown in this slide. Second one is heat input reduction. When the droplet transfer performed, simultaneously the arc ignites, the wire advances and molten pool short circuiting occurs. The wire retraces and the welding current fast plummets to near zero. So this requires to cool down it and reduce the heat input. So let's compare the hybrid CMT process with the traditional process. So on the basis of heat input, we can say STMTW has a lower heat input than traditional welding, which can reduce the risk of detortion and other heat defects. On the basis of weld quality, we can say cold metal transfer welding can produce high quality welds with good mechanical properties, including high strength of toughness. And SCMTW can be faster than traditional welding methods as it combines two processes. On the basis of equipment requirements, we can say SCMTW requires specialized equipment that may be more expensive than traditional welding equipments. Now moving to the next slide and discuss about hybridization of CMT process. CMT process can be hybrid by the use of ultrasonic vibrations. In CMTW, an ultrasonic probe is connected with the ultrasonic generator box, which generates ultrasonic vibrations at a constant frequency of almost 20 kHz. The ultrasonic vibration amplitude is in the range of 11 to 99 micrometers, which is kept constant at almost 66 micrometers for this work. After an extensive number of preliminary welding trials, the different welding parameters are chosen for ultrasonic assisted CMT. Ultrasonic CMT. Thus the CMT can be hybrid by ultrasonic vibrations. Now discuss about CMT welding of similar alloy. CMT welding can also use for similar alloy like Inconel 718 alloy, aluminium 7075 alloy and aluminium AA6061 alloy, galvanized steel alloy, aluminium 5083 alloy, aluminium AA7452 alloy and many more. Now similarly, CMT can give the best results with the dissimilar alloy. For example, zinc coated steel and wrought aluminium 6061, magnesium AZ31 and aluminium 1060 alloy, or magnesium AZ31 band and 6061 aluminium alloy, and hot dip galvanized steel aluminium 6061 alloy and many more. So now move to the next slide and we will discuss the effect of base metal and CMT weld treatments. There is two major effects. One is post weld heat treatment, in abbreviation we can say PWST of CMT weld, and two scientists, Ahmad and Bakar, analyzed the effect of PWST on the mechanical and microstructure properties of welded AA6061 using the CMT and investigated that 3.1% increase was recorded for tensile strength, as we can see in the picture shown here. Hardness strength was increased by 25.6% and 21.5% higher elongation was achieved. The results proved that PWST was able to enhance hardness strength and tensile properties of AA6061 welded joints using the CMT method. Another effect is welding steel sheets treated by nitrogen oxidation using CMT process. So an excessive amount of porosity was observed, probably due to the high content of nitrogen and oxygen in the surface layer of the material and the fast cooling rate of the weld pool after CMT welding. It was observed that the micro hardness values gradually inclined from the weld metal till the heat affected zone. So now move towards the alternative application of cold metal transfer process. CMT can be used for various processes other than welding process, like low dilution cladding of Incol 780 superalloy, cladding of aluminum 6061 alloy, cold metal transfer deposit AZ31 magnesium alloy, and we can say weighting of galvanized steel by aluminum 4043 alloy, steel of aluminum welding, and many more. So now move towards the conclusion. The main conclusions of this study are: the first one is the retention of the wire during the short circuiting phase plays an important role, as it leads to prevention of spatter generation and also produces better weld bead aesthetics. Second one is the laser CMT hybrid welding produces welds with better mechanical properties and aesthetics than the laser welding and laser MIG welding produces. Third one is the post-weld heat treatment PWST causes a positive effect on the weld prepared by uniformly distributing the fine precipitates, whereas the nitro oxidation treatment of the base metal prior to welding caused an increase in the level of porosity, causing a drastic increase in the micro hardness of the weld. And the final, the cold metal transfer welding has a wide variety of applications such as cladding, additive manufacturing, composite joint spin fabrication, and crack repair welding, etc. So overall we can say this seminar suggests that hybrid cold metal transfer welding is a promising technique for joining aluminum alloys with the potential to improve joint quality while reducing welding time and cost. However, further research is needed to optimize process parameters and investigate the suitability of SCMTW for other materials. This is the list of references from where I have studied about this topic. Major part of this topic I have read through Enhancement of Mechanical Properties by Yashwant Kohli sir. So that was all about my seminar topic. Thank you everyone. Have a good day.